and welcome back to GABL. As always, I'm Jonathan.
And I'm Don.
Today we have a really interesting topic for you guys that we discovered last week. And we're going to talk about it.
We're super duper excited about it. I really, I enjoy reading and researching these topics that kind of come out of the blue. And this one is going to be fun.
Yeah, this one was interesting. When I saw it, of course you guys see it by the title, but I don't know what we're titling yet, but you know because you're listening.
That's right.
But when I heard about this, I thought that is the strangest thing. And the thing that tipped my interest with this was the fact that this creature has blue blood.
Blue blood is a blue blood.
And I thought it was some sort of, internet hoax thingy. Mm-hmm. But as I looked into it, it's real.
It is real.
There's a living thing with blood that's blue.
Yes. So what are we talking about today?
We're talking about horseshoe crabs, Don.
Horseshoe crabs, okay. All right, so just a little bit of history on the horseshoe crab. You know that they originally, their purpose was they were used for fertilizer.
Really?
And for feed for cows, yeah. Oh. So back in the late 1800s, early 1900s, they were used for fertilizers for different things.
But they're found in very unique places.
Yes.
They're only found off the coast of the Atlantic coast of northern United States. And
like Delaware and places like that.
Yeah, and what was the other one? They're all the way up in Maine even. Asia. The other one's Asia. So they're found on the coast of Asia. But that's it.
So they were used as fertilizer. And then that practice kind of ended.
Asia's kind of a broad.
Yes, very broad. But yeah, that practice ended in about the 1920s. And the reason it ended in the 1920s is because of the absolute stench that the horseshoe crab was producing in fertilizer.
Really?
Yeah.
Oh.
So they decided to go with
Wait a second. So it was too bad for fertilizer.
Yes. That tells you everything you need to know.
It smells worse than manure. We got to get rid of it, guys.
We got to get rid of it. Yep. So it was pretty bad.
That's got to be terrible.
And so there was not much need for the horseshoe crab, except for then it began to be used for bait. And they were using it for bait for eels and one other type of sea creature. I can't remember what the name of that is. But yeah, it is still actually used today for eel bait. EEL bait.
Yeah, I saw that people are still using them. I was surprised to find that they're not protected or illegal to catch or something, but they're not. As far as my research goes. You can. I mean, they're the same as any other animal.
Yeah.
They are moved to like a not endangered, just before endangered. They're just concerned.
Kind of a concern. Yeah. Yes, I did notice that.
So it's not to a point where the government's going to get involved.
No. So yeah, they were used first as fertilizer, then they were used as bait, and then let's talk about the 1970s a little bit. What has your research kind of pointed out to you about what they started being used for in the 70s?
1970s? I actually don't have a dateline written for this one. I just have several articles that I found, and there's a lot of facts about them.
Okay, so in the 1970s is when they discovered that they had blue blood. Okay, and would you like to kind of maybe go into a little bit about what the blue blood means and how it's used, or did your research take you in that path? Or
the first person to figure out what LAL was, which we'll get into in a second, his name was Frederick Bang. So 30 years before Mr. Ding and 9,000 miles away on Cape Cod, he was collecting horseshoe crabs off of a shore, but we don't really know why. So the resources I found, they don't know why he was collecting them. He was just collecting them to be scientific and whatever he was doing with them.
Okay.
So he was a pathologist. He was interested in the creature's primitive immune system. He settled on a protocol of injecting bacteria into the seawater directly into the horseshoe crabs. And then their blood would clump into these stringy messes. So he's thinking, what is going on with their immune system when I inject this foreign,
bacteria or whatever?
Like white blood cells in us, we get anything that's foreign. Our white blood cells are like, hey, we got to get rid of this. This is foreign. The
white blood cells, they're
this is not self. This is foreign. So we have to attack it. So when he would inject these crabs with something, they would produce this stringy, what he defined as stringy masses.
Okay.
So he was really fascinated by this. So what he did was he figured out it had some sort of clotting purpose as its response to this bacteria. So he immobilized the bacteria by sealing off the rest of the horseshoe crab's body from the invading pathogen. So intriguingly, their blood turned to gel even if the bacteria was boiled for 10 minutes before he injected it to them. So he thought he killed all the bacteria, he injected it into the crab, and it still gelled up.
Wow.
So
okay.
This should have killed the bacteria and sterilized the injection solution, but it didn't. So he realized the blood was so sensitive that it was able to detect bacteria that he couldn't detect otherwise.
Okay, so
this is the guy that figured out that their blood was so sensitive it was detecting bacteria that he didn't name yet, but he figured out that this bacteria that wasn't named yet was called endotoxins.
Okay, so but pausing there.
Okay.
There's something very interesting about the horseshoe crab, in that it's not related to crabs as much as it's related to spiders.
Not. Yes, spiders and
any other arachnids. And the other interesting part
cephalopods, that's what I was going to say.
Yes, the other interesting part about this too is that spiders also have blue blood.
What?
Yes, spiders also have blue blood. So as you're talking about this, think of a spider as well. Spiders have the same thing. The problem with the spider is they don't have...
They're tiny.
They're too small to be able to give enough to study accurately. Let's put it that way. You can study it, but it's easier to study the horseshoe crabs because they have more to give. I guess maybe that was what I was trying to say. So, all right, continue on.
So these toxins that we were talking about, endotoxins, we kind of knew about them because what would happen in the 19th century, people would get injections or shots.
And, like a vaccine?
Yes.
Okay.
And so they would the doctors would just describe it as injection fever or saline fever. Sometimes people just have a reaction to getting a shot, and they weren't sure why, because what they were giving them was what they thought was sterile. Mm-hmm. They said there's no bacteria here, so this is sterile. Some people just get injection fever or saline fever. But what they didn't realize what was happening is they were introducing endotoxins, but they had no way of detecting endotoxins at the time.
Okay, so once again, an endotoxin is a bacteria that is not recognizable by us, basically. That it's so small.
We have these swab tests we can do that detect bacteria, but they can't detect endotoxins.
Got it. Okay, continue on. Sorry.
So what happens with these? Well, I don't know. Yeah. Anyway, so I'll try to do this in order without getting ahead of myself. So at the time Bang was doing the research in the 1950s, the standard way to test for bacteria was to inject a bunch of rabbits. Okay. So what they would do is take their shots or whatever they were going to give to humans, and they would inject it into, let's say, 30 rabbits. And then every 30 minutes, they would check the rabbits to see if they got a fever, this saline fever, because they figured out that it wasn't just, there had to be some kind of bacteria. People don't get saline fever. That doesn't make sense that some people have a reaction to saline and 90% of people don't.
Yes.
When it's pH balanced perfectly to your body, you shouldn't have any reaction.
That makes sense.
So what they started doing was injecting rabbits. It is kind of messed up, but all these rabbits would get sick, and they're like, okay, well, that's not a good batch. We'll start a new one. And then they would keep doing it until the rabbits stopped getting fevers, and then they would give it to the humans.
Got it. Okay.
So before we could detect endotoxins, we had to literally inject a ton of animals.
Wow. I wonder how many rabbits they injected. Do you have that number?
I don't have the number. It just says many rabbits.
I would guess it was in the millions.
Okay, so moving up to, it wasn't until 1977 till another gentleman named Jack Levin, he devised a standardized way to extract this thing called LAL from the horseshoe crab blood.
Okay.
And this LAL component was used to be placed onto a medical instrument or syringe, and then if the LAL gelled up, then they knew endotoxins were present.
That's so device. Cool. Okay, so pausing there, let's talk a little bit about how did they extract this blood? Do you have any research on that?
So these fishermen catch these crabs, and then they harvest them, and they put them into containers on their boat, or sometimes they're harvested off the shore because they come by the thousands to the shore to breed and before they move back out. And then they're put on trucks, and then they're driven to like a breeding facility. The breeding facility is then places them in large containers again for an unknown period of time, and it's probably overnight before they are bled, and then they're placed into they're all strapped in by like this.
They're strapped in. Okay, so they put them like on these racks.
They put them on racks over little mason jars, and they have like a rubber bungee that kind of holds them in place. They try not to harm them too much, but then they fold their tails down. They have these really long tails.
Yes, they look like a stingray almost.
Yeah, it looks like a stinger, but it's not. It's just to help them swim.
Okay, and also I heard that those tails also are, when they're crawling on the beach, if they get flipped over, they're also the one thing that helps them to flip back to proper direction.
All that tail can do when they're upside down is kind of prop them up. It can't actually flip them all the way over. So what they'll do is they'll prop themselves up and wait for water to come, and hopefully the combination of the tail propping, kind of, and the water will flip them up right side up again.
Got it. Okay.
And it's funny because there was actually like a conservation effort in like 1983 that launched it was called Just Flip 'em. And they were telling people that walked alongside the beach in Maine and northern United States that if you see one of these crabs, just flip them. Just real gently reach down under the precipice and grab his shell and flip him over and leave him. And, do them a favor.
Speaking of that, did you ever hear the story years ago about the starfish and the guy that was walking down throwing the starfish back?
Yeah, it's a good story.
Years ago, there was just hundreds of starfish, and they were just there on this dry beach, and so he was walking along the beach and he's picking it up and launching them back into the ocean. Pick another one up and launch it into the ocean. So somebody walked by him and they said, "Sir, what are you doing?" And he's like, "Well, I'm just throwing these back in the ocean." And they're like, "Sir, there's thousands of them. What does it matter? You're not." And he reached down and he picked it up and he throws it back into the ocean. And he said, "It mattered to that one." So I guess these horseshoe crabs were thankful for Just Flip It.
Yeah,
so,
they are. So happy to be alive.
Yeah. So do they do it? Like, do they drill into them to get this blood?
No. So they take a small needle.
Okay.
Like hypodermic needle, and then they once the tail is folded up and the crab is under the bungee, they insert that needle and the blood drips out. Because they don't have veins, they have like an open circulatory system. It just all the blood just flows around in their shell.
Okay.
And then once they poke them with that needle, it'll just drip out. And they drain anywhere from 15 to 30% of their blood, which comes out blue. If you're listening to this, you need to Google it. Horseshoe crab blood.
Yes.
Ridiculous.
It is amazing. Yes, it's like, it's not a royal blue and it's not a sky blue. It's kind of like a cross in between the two almost. It's amazing.
I've heard it described as antifreeze mixed with water.
Yes.
But all the antifreeze I have experienced with is green, not blue or yellow. Anyway, they're draining 30% of their blood and then they're placed back into the ocean.
And now the positive part of this whole thing is they say that so they take 20 to 30% of their blood, but there's only a mortality rate. Many groups say of only 3%.
Yeah, so the people that are involved in the collecting of the crabs and re-releasing them say 3%, but you got the activists, the animal activists that say it's much higher, more like 30%, and they also advocate that the females lay less eggs after being drained of 30% of their blood, which might be true.
Yes, I could see that. Here's the interesting part about it. Is they say that it's not so much the draining of the blood that causes the problem, though. Several different sources of research that I found say that it's the transportation and the storage component of taking them out of their environment, taking them to a facility, harvesting their blood, and then taking them back and sticking back in the ocean. They say that is the part that truly kind of messes with them. Because they did a study that if the boat was there, pulls them out, and harvests their blood on the boat and then sticks them back in, they had a 0 mortality rate.
Oh, wow.
Yeah. So anyway, sorry, continue on.
Well, maybe they should do more of that if that's the case.
You would think so. Yeah.
So one of the diseases that is well known that only can be detected by the horseshoe crab blood, the amoeba sites in the horseshoe crab blood, is E. coli. It is otherwise undetectable. Until very recently being 2007, and when it was kind of being worked on in 2014, when they had a working model of it, is a man-made synthetic that can be used to do the same thing that LAL does, which is extracted from the horseshoe crabs. But this one's man-made, so you don't have to harm any animals.
Okay.
So, but the problem is it's not FDA approved yet.
Okay.
So they're using it in certain countries, but they're not using it in the United States.
So my question, this horseshoe horseshoe crab blood sounds extremely valuable.
It is.
What does it cost to get some of this
It
blood?
supposedly has a worth of $60,000 per gallon.
60? You're kidding me. $60,000
$60,000 per gallon.
per gallon. So a gallon of milk costs
For $3.99.
$3.99,
$3.50,
$3.50,
yeah.
somewhere in there. A gallon of gas right now.
We're in California.
We're in
folks.
California.
Yeah.
Is $2.35 roughly,
Mm-hmm.
probably average.
$60,000 for a gallon.
A gallon
of
of blood.
It is
It's
outrageously expensive. But every man, woman, and child benefits from the horseshoe blood.
Okay, explain that.
Because it's used on everything in the hospital. They use it. They're checking for E. coli and other endotoxins on everything that comes into contact with your
every
skin.
needle,
Yes.
every scalpel, all of those things.
You have to do the testing for bacteria, which is like these swab tests,
Mm-hmm.
and then you have to do the endotoxin test, which is used. You use the LAL, which is amoebocytes from horseshoe crabs.
Wow. So
So if you've ever been to the doctor and any instrument has ever touched your skin, it has been checked with horseshoe crab blood.
and what's incredible about that is FDA mandated.
Yes, mandated.
It's
yeah.
mandated. So
the man-made synthetic is not approved by the FDA.
that's right. So they have to use this horseshoe crab.
And I get it. It is harming some crabs, and some of them do die.
Yes.
But it's a whole lot better than injecting hundreds or thousands of rabbits, injecting them to cause them harm, and then monitoring them and watching them die.
yes.
It's like, oh, okay, that one has E. coli now.
And
Too bad.
the absolute benefit to human health is amazing. Now,
Yeah, I
Do you-
do
Uh,
prioritize human life above crabs.
yeah, so
I know that might be controversial. Sorry. Don.
Yes, but my question is, do you have any idea last year how many horseshoe crabs had their blood harvested?
I would guess 575,000.
You're right on. You're right on. Yeah.
Yeah,
So
you can't ask
they
me questions I've done research
They
on.
basically
Or you can't. You
say
can.
that.
Never mind,
that-
go ahead.
oh, okay. I will. Thank you. They basically say that between 500 and 600,000 horseshoe crabs a year have their blood harvested. It's amazing to me that they harvest this blood and then they use it for all the things that they use it for. Sorry, I'm sure you have more research, but it's just to think that it's $60,000 a gallon. That's what's getting to me. Go ahead. Sorry.
Well, that's pretty much the whole process. That the blood is blue because it's some copper that's present in their blood that makes it blue.
Okay, so they say that human blood, there's an old wives' tale that basically said that, in fact, I think it's where, he's a blue blood, where basically that human blood is blue. But in my research, that's not, it's blue until it hits, so it's blue until it becomes oxygenated or it comes in contact with oxygen. Then when it comes in contact with oxygen, it turns red. That's the old wives' tale.
okay.
But that does
Yeah.
not bear out
Obviously
in research.
Obviously a myth.
Yes, because
my son, who's 5 years old, has figured out this is a myth. And he doesn't know he figured it out, but he did because he was outside. He closed his eyes and he said, "Dad, it's red." What are you talking about, buddy? And I look at him and he has his eyes closed and he's pointing his face is towards his son and his eyes are closed. He's saying, "Dad, I see red." And I'm like, "Oh, I see. Yes, son. That's because your blood is red and you're looking through your eyelids, so you're seeing red."
seeing the red. Yep, that makes sense. They say that the less oxygen your blood gets, the darker it gets. And so it will become, it never turns blue, but it does, the less oxygen, the darker color it will be, they say.
The wise tale is just, I suppose, is from your veins, because your veins do look kind of bluish,
Yes,
greenish,
they do.
right?
That makes sense.
So people would just used to assume that your blood was that color, but that's not the case.
No.
Your veins appear to be blue through your skin.
Yes. So the only ones that actually have blue blood is horseshoe crabs and spiders.
Wow. I did not know about spiders. I thought horseshoe crab was the only thing.
No, spiders have blue blood as well.
Yeah, I heard about this blue blood and I Googled it. I thought, no way. And then I've realized it's the reason I'm alive. There's this beautiful article by, where is it? Popular Mechanics that says the reason you're alive, the horseshoe crab. And it is a great article. And we use it as one of the sources for our episode today. You guys should check it out. They have lots of pictures that are really fascinating.
So the another interesting part of the whole horseshoe crab thing is when horseshoe crabs begin to migrate.
Oh yes, I love. So, are you going to talk about how often they come to shore?
No, I was going to talk about the bird population, but go ahead.
Oh, so they come to shore, and there's some research that points out that we don't know where they go. So they come to shore to breed, and then they
disappear.
They their little hatchlings hatch, and they make it back to the ocean, and they can track horseshoe crabs somehow. Like, oh, this is the same one. I named that one Billy. I don't know how they figure out the same one.
Yes.
Anyway, they don't track it real time, but they realize the same horseshoe crabs don't come back to the beach for 10 years.
10 years. That's amazing.
And we don't know where they go.
Yeah. So in their juvenile state, from basically 0 to 10, we have no idea where the horseshoe crab goes. After they turn 10, they begin to come back for breeding purposes. And so all of these crabs that they're harvesting their blood, they're all 10 years or older. And so they come back, and the females, which are about 30% larger, by the way, than the males.
Yeah.
The female,
oh, and by the way, we have the largest crabs by far. Ours are 40% larger in the northern United States than there are anywhere in Asia.
Wow. Okay, so I didn't read that, but that's interesting. So they come back for breeding purposes, and they lay literally hundreds of thousands of eggs. One female will lay up to 120,000 eggs in one moment. And then, but here's the very interesting part about that. In the tip, or the lowest tip of South America, near Chile, there are these birds, and I can't remember exactly what they're called. I want to say something like the South Pointer or something.
Okay. So there's this bird.
There's this bird, and at the exact moment, they've been able to track that when the horseshoe crab begins to head toward the beach, these birds, their digestive system shuts down, and they fly 4,000 miles. They're headed to the Arctic Circle, but they fly 4,000 miles, and they leave within hours of the horseshoe crab heading for the beach. These birds in South America, somehow, they know, and they leave as well.
Whoa.
From South America. So they leave from a point in South America. The horseshoe crab leaves from wherever it's going. The horseshoe crab gets to the beach and lays its eggs.
Okay.
This bird flies from South America. Their digestive system shuts down, so they have more energy to be able to fly for the 4,000 miles. Sometimes they never even land until they get to these Atlantic beaches where the horseshoe crabs have just put their eggs. And then their digestive system starts up again. The birds land, and they begin to eat and devour tons and tons of these eggs. And so that's why the horseshoe crab's eggs, even though one female may lay up to 120,000 in one situation, they will very few of that number, of a small fraction of that number, will actually ever make it to life. And the reason why so much of that is these birds devour it because their eggs are filled with protein. And so it's their stopping
like
off
most
point.
eggs, yeah.
Yes, it's their stopping off point. They eat these eggs, and then they fly the rest of the way to the Arctic. But they're so it's
like a halfway point, yeah.
Exactly.
Refueling station.
It's a refueling station for them, and without the horseshoe crab's eggs, these birds would not be able to survive.
Yeah, a lot of protein-rich diet that's really all in one place. That's neat. Wow.
Yes, and so not only is the horseshoe crab sustaining humans with its blood, but it's also sustaining these birds as well in their trek to go from
it's
the south to the north.
It's keeping everybody from getting E. coli and all these other crazy infections.
Yeah,
and saving a whole lot of rabbits.
Okay, so let's talk about how that works and how.
Well, I think it's a couple of things I thought about was that guy that was injecting horseshoe crabs for seemingly fun. He's like, oh, it made stringy messes. That's why he was injecting them. Like, that's crazy. What was his name? Frederick Bang? He's just injecting crabs and like, oh, I like the stringy messes it makes. And then he was curious about it, and then he kept researching it and found out that they're just really sensitive to
So basically,
infections.
Any bacteria, just because I'm not a scientist nor the son of a scientist, but just kind of the way. Okay,
I want to say something that is kind of controversial. He was experimenting on a living creature.
Got it.
And it's because of his experimentation. First of all, it came out in stringy messes. He thought, well, that's odd. And then he boiled it, which should have killed all bacteria. Mm-hmm. He injected them, and they still, their immune system still provided that stringy mess, so that immune response. So then he realized there must be some sort of infection present that we can't detect. Mm-hmm. But this horseshoe crab blood is so sensitive, it's detecting it.
Wow.
So it's because he experimented on these crabs with this very peculiar blood was the birth of all this in the 1950s. And then it wasn't until the 1970s till you got the other gentleman I mentioned earlier who extracted the exact amoeba site, LAL, from the blood, which was the clotting agent.
So basically that clotting agent, the way from my research, and correct me if I'm wrong, but basically it does not kill that bacteria.
No, it just surrounds it.
It just surrounds it almost like Jell-O, kind of.
Well, interestingly enough, that's the way the human immune system works. You got your T cells and your B cells. The B cell gives permission to the T cell to surround the foreign invader, and then they surround it until the foreign invader is consumed. And when they consume the invader, they also die themselves. They self-destruct at the same time. Your T cells do.
So basically, though, this blue blood, it never actually kills.
Oh, it never kills it.
It never kills it.
Well, that would make sense because it's removed from the crab. I imagine if it was still inside the crab, the immune system would run its full course and it would eventually kill it.
Yes, but
maybe. I don't know.
Yeah, but they say it surrounds it. It turns into a Jell-O-like substance. And that gelatin just basically, it traps it to where it cannot move.
Yeah, it can't do anything.
It can't move or. And so it's surrounding that blood is just, it is, when you research it, it's so easy to see why it's worth $60,000 per gallon, because
there's nothing else like it.
There's nothing that
other than that synthetic material that's not approved.
That's not approved yet, and is still not even perfected completely. I mean, they are to find.
Well, it's being used, I believe. All of Europe is using it.
Is it?
It's hard to say who's all using it.
So I guess it would be more
accepted.
I guess it would be more perfected than I'm stating. It is perfected, but it is not for the U.S. It is not in a perfected state according to the FDA, at least not yet. Or
who knows what their reasons are for not approving it? Right? It could be just something to do with money.
Yes. Oh, by the way, that bird is called a red knot.
Oh, okay.
A red knot.
I'm glad we found that before we wrap this. We finish the podcast.
Yes. Now they say that a horseshoe crab has really no natural predator, due to their large size and their thick shell. Mm-hmm. But they do think that perhaps the American alligator would eat.
Well, I would imagine.
Yeah, because an alligator is pretty much a scavenger.
He doesn't care.
Yeah, and so
like, something's moving. All right.
Yeah, but they say that other than that, they don't have a lot of natural predators.
Yeah. So, as I was saying about the clotting agent, that was determined to be called, they dubbed that factor C, like they narrowed it down really to the molecule, like, oh, it's factor C that's causing the clotting when it comes in bacteria with the endotoxins.
Okay.
And so that's the thing that they started making in 2012, but still not approved.
Wow. Well,
we're in 2020 now, so anything's possible. It'd be cool if they perfected it and the FDA approved it, because then we could stop bleeding all the horseshoe crab. But until then, thank you, horseshoe crabs, for saving my life.
Yeah, I mean, how many times have they saved both of our lives? And we look at it and we just think, and maybe one of these days, in fact, I know we've talked about it on the schedule, that at some point we're both going to tell our very unique medical histories.
I don't think we have mentioned it, but yeah, we will be. We both have some really extensive, not extensive, but very intense.
Intense is a great word.
Medical experiences.
Yes, and so I think, when I look at the horseshoe crab, I like you have to say thank you, because it definitely has saved my life. And thank you to all the companies who spent $60,000 per gallon. I mean, That's pretty intense.
Well, that would be the medical industry. Yeah, for sure. They are buying up all of it.
Yep.
And apparently you can, I mean, I don't know if you can have one as a pet, but I think you might be able to.
Well, we might have just found a way to make $60,000.
That'd be very cruel. I was like, what is that thing in your aquarium? Well,
why do you have that mason jar next to you?
How do you think I own that Ferrari in the front yard there? Let me show you.
That's it.
Take the crab into your bleeding room. I was like, okay. Poke it with a needle. Yeah, that's really messed up. Don't do that.
Yeah, but I do think that it's amazing, and the fact that this is my question.
Okay.
How, and I know we've talked about it a little bit, but how do people get the idea to look into this kind of stuff?
I don't know. That guy was just crazy. He's a mad scientist, right? He's just injecting. Think about this. He's injecting animals with bacteria.
Yeah.
And then he's like, wow, this one makes his blood come out really stringy. I'm sure the animal was not pleased with whatever this guy was doing.
Sometimes I think, like, how do these inventors, how do these scientists, how do these medical personnel, how did they even get the idea to look in that direction, much less research it? It's like, how did you even think that there might be something in a horseshoe crab that could help humanity in any way at all?
Yeah.
It doesn't make sense.
Well, my question is, would you be able to do that today? Like, that was in 1950, right?
No, you wouldn't be able to.
Let's say you're in 2020 as a scientist. Are you allowed to do that?
No.
Can you just inject crabs?
There would be, in my mind,
exploratory research on animals. Is that?
I don't see that.
I do know they greatly reduced the experimentation on mice and such because of, activist groups and such.
Activist groups, yeah.
But my question is, obviously, I stated earlier that I think human life is more important than animal life.
Yes.
Is that controversial? Because if it is, why is that controversial? And is that going to stifle or even prevent future medical innovations because we're afraid or, there's a negative connotation to experimenting on animals?
I totally, yeah. And I'm saying,
I'm not trying to be provocative.
No.
I'm trying to be real here.
Yes.
Is it going to stifle future innovations?
I would think...
innovation is the wrong word.
Yeah, I would
future
think
life-saving
future human
inventions.
Life-saving inventions, I would say yes. Because I do believe, there again, I'm not meaning to be controversial in any way. I just feel like myself that there is many activist groups out there,
but
whether right or wrong, they are going to definitely limit your ability to practice on an animal.
But playing devil's advocate here, there is definitely cruelty that's unnecessary.
Yes.
That I don't think is cool at all.
No, I totally agree with that.
If someone's harming or being killing or harming animals just for the fun of it, that's not okay ever.
No.
Right?
I agree. But
that's my question.
Yeah,
where do you draw the line, and who gets to draw those lines? So where is the line, and who gets to decide where the line is? I can say, okay, you guys can put them in a pen, but you cannot poke them with needles. Like, where do you draw the line? You can poke them with needles to extract blood. You just can't inject bacteria. Well, if we said that in 1950, we wouldn't have horseshoe crab blood, LAL, that saved or prevents everybody from getting
billions of
E. coli.
Lives. Probably billions of lives.
Yeah, so that's a
slippery slope. That's a slippery slope. I don't have the answer.
I don't even know how to start answering that.
No, I don't either. I think the only thing that we can say is
somewhere in between unusual and cruelty to animals and science, the betterment of humankind with science. I don't know.
And
I'm sure there's groups in place that do that. Maybe it's the fact that you have the animal activists and then the scientists. Then they battle it out.
They kind of balance each other out in a way. Yeah.
Maybe you need both of them.
Yeah, that makes sense.
Just let them coexist, and as long as none of them make these outrageous laws based off of emotion.
Yes.
Either direction, as long as there's a balance between the two.
There's got to be a balance. It's like everything in life. There's got to be a balance.
Well, hopefully we straddle that healthy balance and we keep making life-saving technologies. Otherwise, because we'd all be dead by E. coli.
That's exactly it.
And like endotoxins. That's just the one that I recognize. All the other ones are unpronounceable.
Yeah.
They're not unpronounceable. They're just unpronounceable for Jonathan.
Yeah, unpronounceable for Don, too.
Well, Don, what else do you got? You got anything else on the horseshoe crabs? Any fun facts?
Nope. That's all
they
I've
have
got.
9 eyes. That's one of my fun facts.
Yes,
That is creepy.
It is a little creepy.
They have 5 on top and 2 on the bottom. I don't know.
It's something weird, and they don't have good eyesight.
That's only 7.
So they have. I believe they have 9.
7 on top and 2 underneath.
Yes, and they still don't have good eyesight.
No, the 2 underneath they say aren't even used as they're adults. It's probably just like leftover eyes from their larva state.
Yeah.
Because when they experiment with them, I don't know how they figure this out, but they say the eyes on the bottom of their shell don't seem to be useful.
Okay, here's another question. Who thinks to experiment in these ways?
Yeah.
Like, I wouldn't even think to want to know about the 2 eyes on the bottom. Like,
get this. Out of the 7 eyes on top of their shell, 5 of them are light sensing eyes, and then 2 of them are actually spectrum understanding eyes, like our eyes.
Yeah.
Or more similar to our eyes. Our eyes. I don't know why. I can't talk today.
It's all right. Like, for me, I think the biggest thing with this whole thing is who thought of that? Who thought of that?
No, I think it's just experimentation. I think it's a great argument for the scientists' side of the argument to say, hey, we need to be able to experiment because we were able to discover this amoeba site, this LAL, because of animal experimentation. Yeah. That's a great argument for it because look at it. It's used in every single medical facility.
It makes you wonder what animal...
It's the LAL test.
What animal is carrying the cure to cancer or what bird is carrying the cure to the common cold. Or it just makes you think that it's probably out there somewhere. We just haven't discovered it yet.
Wow. That's deep, Don.
Okay.
Yeah.
I'll move back into the shallow end.
Maybe we should stop there because that's going to transition into our current state of events, which is not cool. So, all right, guys. Well, that's all I have for the horseshoe crab. Let us know if there's any facts that what you guys want us to talk about. You can contact us at thegablepodcast@gmail.com. That's THEGABL podcast@gmail.com. We love your feedback, love show suggestions, and if there's something we missed, we'd love to hear it from you guys, and we will definitely let you know next time.
And by the way, we have been getting some great suggestions.
Yes.
And
keep them coming.
Keep them coming. We're reading all the feedback that we get.
So we're to the point where we're researching them simultaneously, and we are getting to the point where we're going to have complete shows ready to go. So we're going to be able to do multiple shows per weekend and definitely increase our rate of upload for our episodes.
Stay tuned because you're fixing to get a whole lot more GABL.
Yeah, we're excited, and we hope you are too. Let us know what you think, and any feedback you got for us, we appreciate all of it. And we'll talk to you guys next week.
Adios.